When NASA published the confidential results of its latest tests on the development of a propulsion system, the scientific community expected it to cause a minor stir. Instead, it sparked a veritable tsunami. After decades of searching for a way to break the light barrier, the veil was finally lifted on what many had been whispering about in the corridors and forums of theoretical physics. NASA had developed a propulsion system so advanced and revolutionary that it was capable of reaching the speed of light. Not almost the speed of light. Not relativistic. Real. 299,792 kilometers per second. The implications of this admission are truly staggering. The dreams of science fiction are beginning to intertwine with the ambitions of modern physics. At the heart of this discovery is a propulsion system that goes beyond traditional rocket dynamics. NASA engineers, in collaboration with leading quantum physicists and materials scientists, have created a prototype engine based on principles that until recently were considered theoretical or impossible. They appear to have tapped into the elusive zero-point energy and quantum vacuum fluctuations, phenomena that harness the hidden energy of empty space. This energy source has remained intangible and unsuitable for practical application until now, but has been tamed through manipulation of the quantum field and energy storage technologies using metamaterials not found in nature. The result is a propulsion system that uses the energy of the vacuum itself. No fuel in the usual sense. This engine, unofficially named light drive, does not work according to classical Newtonian laws. It does not push mass to create momentum. Instead, it rearranges space-time itself on a localized but controllable scale. The technology echoes Alcubierre's metric, a hypothetical model of space-time distortion proposed to overcome the light barrier. Light drive compresses the space in front of the ship and expands it behind it. Technically, the ship itself remains stationary inside a so-called warp bubble, and movement occurs due to the movement of space itself. Light remains the local speed limit, but this technology circumvents this limit by manipulating the fabric of the universe itself. The experiments that led to the development of light drive were conducted for many years under strict secrecy, under code names as part of NASA's Deep Space Propulsion Initiative. However, leaks and heated discussions in alternative science circles forced the agency to acknowledge the fact of its development. When the data became irrefutable, NASA made an official statement confirming the existence of light drive, albeit with numerous caveats and technical clarifications. But this could not contain the wave of shock in the scientific community. At one of the classified facilities, a prototype spacecraft the size of a passenger car was launched in a vacuum chamber reinforced with magnetic stabilizers. Initial calculations suggested that it could reach up to 70% of the speed of light. Instead, the craft disappeared in a bright flash, crossing the light barrier. Ultra-high-speed sensors, recording at a rate of 1 billion frames per second, confirmed that the ship briefly entered relativistic mode and then disappeared. All that remained was data that would be studied for years. This discovery put an end to the dictatorship of distance in space exploration. Alpha Centauri, the closest star system to us at a distance of 4.37 light-years, had long seemed unreachable. With existing technology, the journey there would have taken tens of thousands of years. But with light drive, such an expedition becomes possible within a single human lifetime. Theoretically, it would take just over 4 years. For generations who grew up on Star Trek and Star Wars, this is the moment when science fiction becomes reality. From a technical point of view, the challenges that had to be overcome were enormous. First, energy. For a long time, it was considered impossible to safely extract and stabilize zero-point energy without destructive quantum effects. The breakthrough came when NASA scientists developed a containment grid made of programmable metamaterials capable of adapting to quantum stress in real time. These materials, built at the atomic level, can bend electromagnetic fields and control energy flows. This made it possible to create and stabilize a vacuum energy gradient, a necessary condition for triggering the space-time compression that powers the light drive. The second challenge is navigation. Conventional inertial systems and reactive controls do not work at the speed of light. Therefore, NASA has developed an AI-based navigation matrix capable of predicting gravitational fields, spatial anomalies, and temporal distortions. This AI does not simply react, but predicts the trajectory of movement using quantum entanglement data and star positioning beyond the visible spectrum. Of course, when light speed is reached, the problem of time arises. According to Einstein's theory of relativity, as an object approaches the speed of light, time slows down for it relative to an external observer. However, light drive eliminates this effect with a warp bubble. Time flows linearly inside it, even if the bubble is moving at the speed of light. This means that the crew can travel to distant stars and return without the time paradox effect. This technology is not just an engineering breakthrough. It is a philosophical rethinking of human nature. Stars are no longer abstract points. They are directions of movement. The entire galaxy, with its billions of potentially habitable worlds, is now within reach. Questions arise. What does it mean to be human when we are capable of leaving the solar system? What will society be like when humans can return from another star in the time it takes a few years to pass on Earth? NASA's recognition also signals the beginning of a new geopolitical era. Space has always been an arena of competition, but the speed of light is changing the rules. Whoever masters this technology first will gain an advantage in access to resources, planets, and research. This is not just a new space race. It is a race for interstellar presence. And it is no coincidence that NASA's recognition came amid accelerating developments in other space powers. It is both a warning and a declaration. We are also facing a psychological shift. For centuries, people have looked at the stars as something divine and unattainable. But light propulsion destroys part of this mystique and replaces it with opportunity and responsibility. Space is no longer just a dream. It is a direction of development that requires cultural, ethical, and legal solutions. Light drive also changes our very understanding of physics. It demonstrates that traditional speed limits are not absolute prohibitions, but rather transitions. This breakthrough supports alternative interpretations of quantum field theory and provides grounds for considering hypotheses that were previously considered marginal. The line between science and science fiction has become thinner than ever. This discovery will inspire future theories, help us understand the nature of dark matter and gravity, and perhaps bring us closer to a unified theory of everything. The significance of this moment cannot be overstated. Light propulsion is the key to the galaxy. Worlds that were previously inaccessible are now a real possibility for exploration, observation, or colonization. The expansion of human civilization beyond Earth is no longer a hypothesis. It is a course confirmed by engineering, science, and now, proof. But with this technology come challenges. Who decides where to go? Who funds the missions? Who is responsible for the possible consequences? However, the most important motive remains the same as it has always driven humanity to the stars: curiosity. Light drive is the embodiment of curiosity brought to life. It is a triumphant response to the silence of space. With this breakthrough, the final frontier is no longer a metaphor. It becomes a coordinate on a map. And although this engine is a miracle of science, it is driven by something much older than any elementary particle: the human desire to go further, see more, and understand what lies beyond the horizon. This is not just a step forward. It is the beginning of a journey that has no end, a journey illuminated by light, alongside which we are now able to move.